Welcome and thanks for attending today's Ask CTE Contributors webinar event. I'm Dennis Spaeth, and the owner and publisher of Cutting Tool Engineering. I'm going to serve as moderator. Before we get going, I'm going to point out a few things about the GoToWebinar platform that we're using. The screen that you're looking at on your computer, you should see something like this control panel on the right here, something similar to that. That is the control panel, and I want to take a closer look at that so that everyone knows how to submit a question if you'd like. So this button here, just so everyone knows, if you click that, it'll collapse the control panel so you can see your screen better if you want. And then just click that same arrow again to reveal the control panel. If you have a question or if there's some sort of a technical issue, you can press that raised hand icon right there, and I'll do my best to work with you to see whatever the problem might be. If you want to, you'll be able to download, there's one handout for today's event, and if you want to download it, it's the article, the PDF form, and you would just click on the PDF that you want in this area, and once you do, it'll open up a web browser window, and you can save it as a PDF from there to your desktop. If you want to ask a question, which I hope you will, the question area is right here. You will type your question in this area here and then hit that send button right here so that it shows up in here so you know that it's been submitted properly, and we'll get to it as soon as we can. So Deburring, today's webinar is based on this feature article in our June issue of Cutting Tool Engineering. The deburring and chamfering article was about manual deburring and chamfering machine parts and moving it to an automated process. This was written by James Engineering, and which, you know, it's a company that offers an 11-axis Max System CNC deburring and chamfering machine. Along with the article, James Engineering submitted a brief video about their machine, and I want to take a quick second here. It's only just over a minute. I'll play that for everyone in case you haven't seen that.
What do Pratt & Whitney, GE Aviation, Boeing, Boston Gear, ZF, Allison Transmission, John Deere, and General Motors all have in common? They all utilize a James Engineering deburring system to save time, money, scrap, and injury in their deburring processes. All systems come pre-programmed with your recipes, and you can easily add more to the control panel. Utilizing up to 4 overhead servos, these systems can achieve up to 25-axis synchronized motion. Our systems are lightning fast. According to our survey, our customers save an average of 48 hours with every 100 parts deburred.
I want to just mention that normally we like to have the contributors, the author or the author of the feature article on hand for this webinar, whoever it was that participated in the article or writing the article. But unfortunately, I did not secure a representative from James Engineering to participate in today's event. So I'd like to blame the Canadian wildfires for this predicament. But it's on me for my own time management problems. Instead, I have reached out to a friend and a 43-year machine tool veteran to do his best to field your questions today. Terry Iverson is the president and CEO of Iverson and Company, a machine tool build distributorship and rebuilder in Des Plaines, Illinois. It was started by Terry's grandfather more than 90 years ago. Before we get going with a couple of questions that came in during the registration process for this webinar, I want to promise to follow up with each of our attendees today. If you submit a question, we can't get to it or we can't answer it, I promise that I will follow up with each of you individually to get an answer to your questions. So now with that, Terry, before we go to the first couple of questions, I thought this would be a good time for you to just maybe give everyone a little bit of background about Iverson and Company and how it's been in your family for over 90 years.
Oh, okay. Okay. My name's Terry Iverson, and I'm the owner, president, CEO of Iverson and Company. We started in Chicago in 1931 when my grandfather used to work with a machine tool builder in Chicago, and that builder moved to New York, and rather than follow the company to New York, he stayed in Chicago and started our distributorship. So we have about close to a dozen people in our company, and we do machine tool distribution service, engineering services, turnkey, and rebuilding. So
here's the first question that came in from a registrant asking for some help about how to get rid of burrs that are showing up on a 4/1000 inch thick piece of 17-4 stainless. So Terry, what do you think would be a good solution for removing those burrs? Oh, and if you want to turn on your webcam at this point, you can.
okay.
There you are.
Well, first of all, anything that's 4,000 thick and made of stainless is going to be a challenge for any operation. I have a lot of experience in turning, milling, and grinding. And so generally speaking, deburring can be done a lot of different ways. Manually, it can be done automated as the video showed. But when you get into something that's that thin, I would think you would need either some sort of a slurry process or a media like they have very fine stones that are almost different porous type of material with a liquid to lubricate the part that gently through a vibration type of bowl go over the part and not deform the part, but yet still finish the rough edges, so to speak, on a deburring operation. But I would think with something that thin that clearly it's going to have to be, it's very delicate, and even if you do it manually or in an automated fashion, you're going to have challenges. So I think this is one that I would definitely reach out to an expert in the field to embellish and build out, what I've stated, a little bit further than what I've been able to add.
Okay, thanks, Terry.
Mm-hmm.
The other question that came in before the webinar was how do you reduce manual deburring on small tight tolerance parts?
Well, the one thing I'll correlate this to is to either turning or milling, for example. When you have tight tolerance parts, many times, it's a very costly part, and has, tolerances in the low tenths range. And so the part is an expensive part to begin with. So many times while the machine is performing the machining operation, the easiest and best way to do the deburring is in the machine, even though it's going to cost you more to do it. But the cost of possibly manually deburring it maybe the risk of damaging the part, in terms of a real close tolerance application. So many people will come back with an extra tool while it's still being held in the operation and perform a deburring operation on the actual machine tool itself. Now, mind you, that's going to be one of the more costly ways of doing it, but you have to consider the overall cost. And the overall cost is, what's the cost of damaging the part or that close tolerance, even if it's offline. So there's a balance between deburring it manually offline, such as the operator while he or she's standing at the machine. Maybe you might want to deburr it manually and have a fixture so that the risk of damaging the part or not adhering to the tight tolerance. But clearly, the tighter the tolerance, the more expensive the part. So it's a great question, and every application and every part is different, and every shop is different. So there's a number of different ways to reduce the manual deburring. But on a close tolerance part, my read would be try to do another pass or another operation while it's still being held in the machine tool.
We can take questions from anyone who's attending right now if you have them. But while we wait for that, if any questions come in, Terry, I thought I would take this opportunity to ask you, since the article is more or less about, taking a shop from manual deburring process to an automated process, which would involve purchasing a machine that may cost quite a bit of money. Can you go into what it is that, a good way to look at that ROI analysis to see what it would take to know if it's a good idea for a shop?
Well, I think one of the things, Dennis, that we talked about when you and I reviewed the article and the video is, I do get involved in capital equipment quite a bit, and that's what I spend my career doing, is selling capital equipment. And when you look at the volume that you're doing and that you need to deburr, that's going to dictate what you can justify or not. So if you take a capital expenditure of somewhere between 100,000 and 300,000, which is a big range, and you look at amortizing it over a payment plan, so to speak, of either 3 years or 5 years, what I came up with from a calculation standpoint, you could be as low as, say, $100,000 on a 5-year plan at roughly $13 an hour in terms of your cost, to the opposite on a 3-year plan and a $300,000 machine, somewhere around $50 an hour. So at the end of the day, it really depends on the volume of the piece. There's a whole element of what is allowable from a depreciation standpoint and the benefits that we have as a shop to depreciate the cost and take advantage of Section 179 and accelerated depreciation schedules. But at the end of the day, if you're making 10 pieces you have to deburr, and you're making 1,000 pieces or more that you have to deburr, your answer is very different. With the labor situation in our industry, in terms of skilled labor and having adequate skilled labor, a lot of times you're going to be in a position, or you may find yourself in a position, that you want to automate something that's being done manual because a worker may be retiring, or you have a very difficult time retaining or getting additional people for the additional volume you're doing. So a piece of capital equipment, if it fits the part designate, one of the attendees asked about a 4,000th thick part. That's a very difficult thing to automate, in the sense of what the video showed. But if you're doing components that are very similar, families of parts, higher volume, and repeat business, that's going to lend itself to doing more things automated. The more difficulty you have with training people to do deburring, making sure you have an adequate staff to do manual deburring, that's an art form in itself, and that doesn't come without its risks and trials and tribulations either. So I think, in a nutshell, what I try to comment to this element is it really depends on your part designation, your workforce, and the volume of parts and the configuration of them, whether you can adequately or easily or justify an automated deburring component.
Before the webinar, we were talking about the potential range of cost for a machine such as the one that James Engineering offers. Not sure what that machine costs exactly, but just a bit of research I did, I mean, if we're talking about a high volume deburring machine, you're looking at anywhere from $100,000 to $285,000 for that kind of a machine. There are other automated deburring machines that are much less expensive than that, but not necessarily high volume. And then there's the vibratory style as well. There's quite a range of options out there. So, I mean, when you're like basically what you've been explaining, I think is just, it depends on how many parts, and the intricacy of those parts. You suggested some sort of a slurry or something like that for the stamping question. There's all sorts of different machines out there that can be used.
Mm-hmm.
What?
Well, they have stones, like we have an indicator company, and I know they do some deburring, Dennis, and they have a vibratory bowl with stones, and then there's a liquid mixture as well in with the stones, and then it slowly vibrates the parts so that they travel through this media of stones, which in all rights, many of them are very, very fine. There's not a lot of abrasiveness to it. But over the course of many, many minutes, in some cases many hours, it's very delicately deburring, a collective group of parts. I've also seen, my uncle had a shop, a very large shop in Wisconsin, and he had parts that had holes down inside. There were fluid type holes for either hydraulic components or what have you, and they had like a putty type of media that they would under pressure press through the through hole or the orifice, I'll call it, and so that type of slurry would have just the mixture itself would have an abrasive component, and that would deburr internal elements of a part. So those are just two samples that my family personally have been involved with.
I don't see any questions coming in, but if anyone does have a question, please jump in. Now, there's a number of companies out there that I'm quite familiar with. There's the Orbitool that is offered by JW Dunn, right? Yeah. And they do the cross-hole deburring, which I don't see how that could ever be automated. Because they go inside a part to get the burrs off of that section, a cross-hole element that's in the middle of a part, let's say. So they've got this flexible deburring tool that manages to get inside there. I mean, could you ever imagine that being something that's automated?
Well, I think one of the tools that I've seen is a chamfering tool. I think this is what you're talking about, that you go into the hole for cross drilling, you go into the hole with a dead spindle, and then when you turn the spindle on, an actual insert through centrifugal motion opens up as it's spinning and allows you to back chamfer a part, back chamfer an ID, so to speak. And then after you perform the operation from a chamfering component, then the spindle turns off. When it turns off and stops abruptly, the insert swivels back, and then you can come out. And that's a pretty trick. I've always been fascinated with that technology because it's pretty simplistic in what it does, but very effective. I think that's what you're talking about.
It's got to be similar. I'm going to see if I can show you the specific thing that I've been talking about here.
Okay.
Showing you some videos and a demonstration of how the Over tool works and what are its advantages. So the main kind of principle of this tool is two main components. It's a flexible shaft, flexible stainless shaft, the carbide cutter, and the protective ring above the carbide cutter. The purpose of this ring is to protect the wall surface of a cross hole. Any sort of wall surfaces where you don't want any damage, this ring will be protecting those. And the carbide cutter is only going to remove material selectively at the intersection edge. So we can step over here and watch a couple of videos on how it's working. You can use the tool manually in essentially a rotary grinder type setting, or you can use it on a CNC machine, either a lathe or a CNC mill. So here in a manual setting, we have this is essentially a 90-degree elbow with a cross hole burr at the intersection of those two holes. The cutter comes in, and we'll pause it for a moment. The protective ring is what's going to protect all of the wall surfaces, and the carbide burr will remove material only at this intersection edge. And now this is being used in an electrical rotary grinder, and the operator is just moving the tool very easily up and down. So we can see it here again. Cutter comes into the hole. We start the tool up, and now the operator is making a very light filing motion. So only remove the burr and no damage is done anywhere else. Conversely, we can use the tool in a CNC setting. So here again, we see the protective ring on the end of the tool. The ring is riding along on the wall surface, and the carbide burr is never touching that wall. So in this scenario, we're going to see it in a lathe setting. The part is rotating while the tool is feeding in. Essentially, we're turning a thread. We're making a thread spiral on the inside of this hole. Now, as we mentioned earlier, in addition to this protective ring, we've got the flexible shaft. So in this CNC setting, we're actually preloading the tool against the wall and bending that flexible shaft. So now we're developing this potential cutting pressure. And as soon as the tool reaches the edge, the disc moves past the edge, and now the carbide begins to deburr. In this case, it's an elbow. Same type of intersection can be a T. This would be very common in hydraulic manifolds or hydraulic fittings, elbows and Ts. So same principle here. The flexible shaft is allowing the tool to build this cutting pressure, and then all of this movement that you see here is happening automatically just by the give of the shaft. The tool is adjusting to the surface as it finds it. We can fast forward a little bit to a mill setting. Same exact principle. We're making a threading motion on the inside of a hole. So either we interpolate the tool around that hole ID, or the tool is stationary and the part is rotating. So now I'll show you a demonstration of that manual, the manual deburring technique. So here we have the cutter, flexible shaft, the carbide burr on the end, and the protective ring. Ordinarily, we never want to spin the tool outside the hole, but we'll take a little risk here for this video to show you. Well, I'll keep the tool stable. just to show you that when we run the disc on the fingernail, it doesn't do any damage. It only begins removing material at the edge of the intersection, but no damage on the wall. So here we have an example of a hydraulic manifold. Essentially, this is your cross hole. This is basically a manifold that was cut in half. And you have a series of cross holes that are drilled into the main bore, and that's where you're developing your burr. So we can try to put it in this way so you can see it, and I'll deburr it from the back. So I enter the hole. Where are we? Here we are. I enter the hole. I don't do any damage to any of the wall surfaces. This protective ring is protecting all of the walls, and it's only when I come into this edge that I cut the burr. And the more time we spend, there, the burr is gone now. The more time that we spend there, the more of the larger radius that we're starting to generate. So in this case, I can see what's happening, but if I'm the operator deburring this part in a real life setting, because I can't damage the wall in any way, I can really do this in a completely blind setting. I'm doing this entirely by feel. So that's the deburred hole, and no damage done to any other surfaces except where we actually need to remove the burr. Now we can see an example of this in a CNC setting. So here the geometry of this intersection, whether it's a T fitting in the hydraulic fitting setting or it's a manifold, it's really the same geometry, one hole drilling into another. With this flexible shaft, we're going to preload the tool against the wall, and anytime we're inside that hole, we don't do any damage to the wall. Only when the cutter is going to reach the edge, then it begins to cut. And because we've preloaded and flexed that shaft, it's going to automatically pop in there. So here, this is the final condition where the tool is fully against the wall. And when we're inside the hole before we reach the edge, then we've got this bent condition.
So I just wanted to show that to you. Terry, are you, I mean, what are your thoughts about the orbit tool? I'm not sure if it's something that can be, you know, built into an automated process. I suppose it could, but.
I think that's an awesome mission. I had not, until you showed me that, I'd seen that particular tool. I've actually seen it, but didn't understand it. So I think that's an awesome component. And I would think potentially you could put that in an automated fashion. But the one thing I also wanted to mention that I don't know if you've seen, Dennis, and some of your viewers may or may not have, is there also is a process called electrical chemical deburring, called ECD. And there's a lot of aerospace companies that have used electrical ECD type deburring, which is kind of a, well, it isn't kind of, it is a manual process, but you're using electrical charge to help deburr very difficult parts. So I wanted to throw that out there as also something that I've seen and I've had a little bit of exposure to, that I would say that that's something that should be mentioned as well.
Okay. I'm going to throw it out again to anyone for any questions out there. If you want to type it out, raise your hand if you have a question. Click that icon and I can potentially unmute you so you could just ask your question through a microphone. Just, well, I'll give this a few more minutes. Anyone who wants to download that PDF of the article that we're talking about today, it's right there in the handouts section of that control panel. It's called June 2023-deburring. It's a PDF file. And if we don't have any questions, I'm inclined to wrap up the webinar early. But if there's anything else, Terry, that you can think of that might help anyone out there who's got some deburring challenges.
Well, I think the one question that I would ask is, how we can learn more about the manufacturer that wrote the article, either through their website or additional information. I think the article had this information, but it'd be probably appropriate to note that as well.
Sure, that's a good idea. Actually, what I'll do is throw that up here.
While you're doing that, Dennis, one part that I remember seeing years ago was a guidance system housing. And just to give you an idea, this particular housing, they had dozens of operators with microscopes looking down into a bore that was about 7 inches long. And they were meticulously manually deburring. And I want to say that there was probably between 20 and or more hours per port, and there was probably 6 ports to this housing. So deburring, it can be a very costly and very intense solution to search for, needless to say.
Yeah, the website for James Engineering is www.james-engineering.com. This is their homepage, and they have information on here to you just click on the contact us button, and you can either reach them in their Broomfield, Colorado office if you're happen to be in the area, or reach out to them at that phone number, 303-444-6787. They do have a sales email address, sales@james-engineering.com. Their website has information about their company and the products they offer, so, and the services. So if you wanted to check that out, just go to www.james-engineering.com. Okay, so Mark is asking, most of what I'm seeing the machine deburring is gears. Would it be able to handle small yokes with cross holes? Mark, are you talking about the video that I was just showing with the Orbit tool, or are you talking about products that you've been looking at in the market? If you could, I'm going to unmute you, Mark. Hang on just a second. I'm not sure if you have a microphone, Mark. Can you reply to your
Is that
question?
Can you hear me now?
Oh, yeah, there you are.
Okay, sorry, I probably had it on mute. I was wondering about the James Engineering deburring machine, and if it's capable of doing more than, say, just gears or teeth like that, and something where you might have ears on a yoke, you're trying to deburr around the edges of that, and so that's kind of what I'm talking about.
Okay, well, and I can't speak
with cross holes too on that. So.
Okay. To give you a complete and accurate answer, I will contact James Engineering and have them get in touch with you directly, if that's okay.
Yeah, sure, that sounds fine.
Okay. Have you seen anything else from James Engineering in the past?
I have not.
Okay. All right. Any other questions from you?
No, thank you.
Thanks a lot, Mark. All right. Is there anyone else who has a question similar to Mark's or anything else? Well, I do appreciate everyone showing up for today's event. Appreciate your time and your attention. Hopefully you'll be back again for next month's webinar, and coming up in July. Frankly, I'll show you what it is. If If you go to our website, you can see all of the webinars that we have scheduled the rest of the year. We try to attach them to articles that are in each of our issues that coming up for the rest of the year. So in July, it's July 26th. It's going to be based on a finishing article. That's just a half-hour long webinar. But you see we have micro machining coming up, reaming, grinding, parts marking, and machining medical parts, medical materials in December at the end of the year. So if you want to join us again, I appreciate it. And I want to say a huge thanks to Terry for agreeing to jump on this with me. You helped out a great deal. And with that, I'm going to end the webinar. And if anyone wants to, they can watch a recorded version of it within about a day. It'll be up and available to everyone. You'll probably get an automated email letting you know that it's available. Thanks so much, and I'll let everyone get back to work.
Thanks, Dennis. Thank you.